A gardener wishes to know if his plants, or if plants which produce only a few potatoes, produce larger ones. He selects 5 plants at random, sieves out the small potatoes, counts those remaining, and weighs the largest ones. So, 5 potatoes, weigh to the largest 240, so on and so forth, the table's there. Calculate the sample product moment correlation coefficient, R, and comment on the results. Well, you should know your formula now for R, and R is SXY over the square root of SXX times the square root of SYY. So we're going to need to know all of those little bits and bobs. Now, you should remember that SXY and SXX, they're all run a similar theme. So SXY is sigma XY minus N X bar Y bar. Sigma XX, you all know from standard deviation, sigma X squared minus N X bar squared. SYY, you should be able to work out. And anyway, you've already seen the video before this talking about what all these are. And so this gives us our product moment correlation coefficient. So I'm going to need the following numbers. Now remember, my recommendation is you always write out these numbers. I'm going to need sigma x squared, sigma y squared, sigma xy, and then I'm also going to need the value of n. I personally always write out x bar and always write out y bar as well. Now obviously I'm going to do this in a nice little table on Excel, but you can use your calculators. I'm done, if not I'm going to do a video on how to do this if I haven't already. So here we are with our x and our y. So I'm going to need the next column, which should be x squared. Having got the x squared values, it's those numbers squared, I then do one called y squared as well. And so y squared is just going to be 240 squared. Then the next one is going to be xy, and xy is going to be 5 times 240. The joy of Excel, all I have to do is copy and paste those down, and my table's filled out. So I just need the sum of those, and I'm good to go. Now this should give me pretty much everything that I need. Obviously the sigma y and the sigma x are to work out x bar. So I'll put mean of x, because I don't know how to write bar in this thing. So mean of x, that's going to be 35 divided by 5, because there's 5 numbers. And then I'm also going to have mean of y, which is going to be that divided by 5, because again there's only 5 numbers in each of them. So I've now got my values. That's everything that I need. So I'll just put these in bold, because those are the ones I'm needing. So what I'm going to do is substitute those into my nice little formula. So can I just copy and paste these? Let's just hide the table and see if I can copy and paste this into my program. Look at that. Oh, modern technology, eh? So that gives me sigma x squared being 263, sigma y squared, so that's 258462. Let's just tidy it up a little bit. 258462, 7875, and there's 5 people, and the mean of y was 227.2, and x bar was 7. Then I'm going to plug them in. Sx equals, so it's sigma x squared, which is 263, minus n, so 5, times my mean of x, which is 7, squared. Now, you can work these out individually if you want, and so Sxx actually comes out to be 18. Then I'm going to do Syy, and again I'm just nicking the numbers from the table that we've got there. So that's, what am I doing? Sigma y squared, so 258462 minus n times y bar, which is 227.2 squared. And again, you can plug all the numbers in the calculator. So what's this? This is 362.8. Yes, the theme is Blue Peter, and I have all the answers already written down somewhere. So SXY 7875 minus Peeper. Honestly, what does Peeper even mean? 5 times, now I haven't done the mean of, oh yes I have, because it's the mean of x times the mean of y. Mean of x, so 7 times by the mean of y, 227.2, and this one comes out to be minus 77. So I then plug all of that into my little value of r, so r is sxy over sxx square rooted times syy square rooted, and so my values are minus 77 over 18 square rooted times 362.8 square rooted. And what's that give me? That's minus, let's just move over a little, 0.953. And so there is my product moment correlation. Obviously it works pretty similar to Spearman's rank. +1, perfect positive correlation. -1, perfect negative correlation. 0, no correlation. But we're not ranking them first. It takes actual data. So that is an incredible negative correlation, i.e. the larger the potato, the smaller the crop size, which is what the question asked. And that's it.